Okay, here's a situation. We've got this city called Centerville that's located at 9,0, or maybe perhaps we could say 9 miles east of this origin. And then we've got Springfield and Shelbyville at 5 miles from the origin, north and south. And we're going to find a point here where we can run cable, the minimized point. And then we're going to branch off to these two cities with more cable. And we want to find the point along the x-axis that will minimize the amount of cable. Okay, and so you can see what's happening. Focus on the length of cable. If I move this point at different spots, the cable length required becomes different. And so obviously there's a point in here somewhere where the amount of cable is going to be a minimum. And I can set the X value to that point. Looks like 17.66. Anywhere else, the amount of cable is greater than that amount. Okay, question is, how do we do that? So let's go back to Wyzant. We got to come up with a cost function. We're going to let this distance right here be X, and the distance from the point that we're trying to find to Centerville will be 9 minus X. And now these are right triangles, so this distance we can find by the Pythagorean theorem. This is 5. This distance is 5. So these two distances are the square root of x squared plus 25. And of course we add on the length from the minimized point to Centerville was 9 minus x. So here's what the function looks like. We've got 2 of those x squared plus 2 of those square roots of x squared plus 25 plus the 9 minus x. That's the function. We'll plug in numbers between 0 and 9 and we'll get the length of cable. And so to find the x value that causes the minimum length of cable, we're going to find the first derivative, set it equal to 0. So we'll just apply the power rule, rewriting this radical as x squared plus 25 to the 1/2. There's the power rule, followed by the chain rule. The derivative of the 9 is a constant, 9 is 0, and the derivative of minus x is minus 1. And this first term here simplifies to 2x over the square root of x squared plus 25. We want to know, when does that equal 0? Well, there's the equation. Multiply both sides by the square root of x squared plus 25. We've got a radical equation now. Square both sides, solve for x. X equals plus or minus 5 radical 3 over 3. We'll reject the negative because we're looking for that point between the origin and 9, 0. So this is the x value that we think causes a minimum. We could plug values between 0 and that number and 9 into the first derivative, applying the first derivative test. But your problem said apply the second derivative test. So we got to find the second derivative of this expression using the quotient rule. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Rewriting in radical form, the easiest way to simplify this is to multiply numerator and denominator of the big fraction. This is a complex fraction by the square root of x squared plus 25, which is this one little denominator. That clears the equation of the little fractions. And times this first term in the numerator gives us 2 times x squared plus 25 times the second term in the numerator. These cancel out, gives us a minus 2x squared. And in the end, this is the second derivative. And we make note of the fact that this is always positive. So if we substitute the critical number into the second derivative, this critical number right here, we're guaranteed to get a positive number. That means the curve is always concave up, which means that critical number creates a minimum value. Okay, there you go. Hope that helped. If you have any questions, post a comment.